All right, welcome to an exciting video of energy, and we'll see how you guys can handle this problem. So hopefully it will help prepare you for all the fun assessments and excitingness that is the physics related to energy. So here's your scenario. You get a car, it's got a mass of 1,500 kilograms, it's speeding down a hill at 14 meters per second, which is a little over 3 miles an hour, so it's speeding. The driver of the car must stop at the red light that is 100 or is 20 meters ahead of them. So like stoplight is like here, okay? Stoplight. It's there, light. Apparently it's like totally red. If the car is 5 meters above the ground when they hit the brakes, determine the force the brakes must apply to stop the car before going into the intersection. So they're at basically this location. They are 20 meters away from the stoplight. They are 5 meters off the ground at this point. I could have given you an angle, but I decided not to make you do trig. I'm just saying. You got to figure out how much force must the brakes apply to stop the car. Okay, so obviously it's the energy unit, so there's your hint, but see what you can do. Try and solve it. I'll get back with the answer in about, I don't know, 5 seconds. So work on the problem, pause the video, see what you can do. Okay, if you have not paused it by now, I'm judging you. But here we go. The answer, if you did this correctly, is 1, comma 0.25 newtons. That's your force. That's your braking force. All right, so if you got that, you're awesome. If not, I got a hint for you. All right, here's your hint. Boop. It's called your LOL diagram. Hopefully you drew one. Hopefully it looks like this. All right. So I hope that jogs your memory. I hope it makes sense because this guy starts off the ground. I don't know which is more. I just know it starts off the ground and we have kinetic energy because it's moving. So that's that. At the end, it comes to a complete stop. So you have nothing. So you should have no energy whatsoever. So where'd all the energy go? Well, it left the system in the form of work. So work done to stop the car, things like that, friction, heat, blah, blah, blah. Energy gone. So assuming it's ideally transferred into the braking force, you should now be able to solve it. All right, so try again. See if you can finish it before I finish it. Hopefully your next step was to, was to yell, no, come on computer, work with me here. All right, boop. Once you have your LOL diagram and you've listed out the energy forms that are present, you can replace those with the necessary equations. Now, we don't always have to solve them all the way out because it depends what the problem's asking, but since the problem is asking for force the brakes must apply, I'm busting out the force there. So just keep that in mind when you're trying to solve these problems. So now it's really a matter of subbing and solving. So you can be able to do the answer. I mean, see if you can race me to it if you want to practice your algebra skills. So pause the video or just embrace the excitement that is. I'll try that button. What does that do? I don't know. I still hate this thing. There, just there, delete. Okay, poop. There you go. So you can see I kind of work it through. Sub all the problems, do some algebra, and you get your 11,025 newtons of braking force. So hopefully you got it right. Hopefully if you didn't, this still cleared up some of your issues. So hope that works. And I'll see you next time.